Rocky Mountain Institute has put out this report with very nice figures, in fact, and the tagline is also very interesting. It says peak fossil fuel demand for electricity. It's all over except the shouting. Wow. Isn't it great that we may be already hitting peak oil for electricity, peak oil demand for electricity? Peak oil is a terminology that's been around for many, many decades. People kept on forecasting that we will run out of oil at some point, and it's not happened yet. But it's clear that ultimately it is a limited resource because we are digging up the fossil fuels that have formed in the past, and on the other hand, renewables like solar and wind are in fact unlimited because the sun is not going anywhere for 100 million years, when all the water on earth may become water vapor because of the expanding sun and increasing luminosity, but wind will be there as long as sun is driving the circulation on earth. So the idea is fairly straightforward, but the numbers do suggest that we may be beyond peak fossil fuel demand for electricity. Demand for fossil fuels has peaked in the electricity sector. There are many other sectors where it's still playing a big role. It will plateau for a few years and be in clear decline by the second half of the decade. So we are talking really soon. The key driver of change is the rapid growth of solar and wind electricity generation on typical S-curve, driven by low costs, a shift of global capital, and the rising ceiling of what is possible. In 2022, solar and wind produced 600 to 700 terawatt hours of new electricity. Added to the 100 to 200 terawatt hours from other clean sources implies that clean energy will supply projected global electricity demand growth of around 700 terawatt hours, and that means peak fossil fuel demand. Excellent optimistic news, but we know that the geopolitics are still playing out in terms of the Russian invasion of Ukraine, need for new infrastructure for handling renewable energy, lots of investments needed in countries like India and China, and of course Africa has remained totally deficit in terms of access to electricity. So we have to worry about those things still. But the story just gets better. As solar and wind advance further up the S-curve, their electricity generation will grow threefold by the end of the decade. That will increasingly push the fossil fuels out of the generation system. This is a global phenomenon. Fossil fuel demand for electricity has peaked in 95% of the OECD countries, Organization of Economic Cooperation and Development, Organization for Economic Cooperation and Development countries, and 31% of the non-OECD countries except for China. Chinese demand is about to peak as the 2030 renewable deployment goals are hit before 2025. So we'll see some data that says China is going gangbusters on solar and wind and meeting the targets in advance of the target year. India is choosing its own path in development based on growth from renewables, and renewables offer new solutions for Africa as well. We looked at the Indian numbers before in terms of how it's made electricity access possible for all its people faster than any other country so far. There are plenty of barriers to change, but none of them can maintain the status quo by being insoluble, immediate, and universal. We are far from the limits to change, and disruption of the incumbent fossil fuel system is thus inevitable. So this change is already here, and it's gonna just end up reaching its expected destination in terms of the end of fossil fuels for electricity eventually, past the peak for sure. Peak, plateau, and decline of fossil fuels in the electricity sector. So you can see here in terms of terawatt hours from 2010 to 2030, fossil fuels, so growth at 2% per year till about 2018, the plateau over 2018 to 2025 projected and decline at 4% year, 4% per year out to 2030, and nuclear is going to grow a little, and solar and wind are expected to grow with this S-curve that we talked about. Okay, so just remember that from 2025 to 2030, fossil fuel electricity demand will likely decline at 4% a year as renewables get in onto the steep part of the S-curve of growth. Fossil fuels are scarce, so if you're looking at world coal deposit in punctiform, fossil fuel deposits are highly concentrated. Just 9 countries with 8% of population control 90% of the global oil reserves. 4 countries with 3% of global population control 57% of the gas reserves. This has been an issue in many ways in terms of geopolitics, especially the battles in the Middle East with all the outside players playing a role, plus the geopolitics of precious or critical minerals and their processing and their concentration is also something we discussed in another podcast. Petrostates charge fossil fuel users rents of an extra $1 trillion a year for the privilege of scarcity, and around $2 trillion in 2022. So profiteers ramped up their profiteering in light of the perturbations to the markets based on the Russian war and other factors. Nearly 80% of people live in countries that are net importers of fossil fuels. So you can see the distribution here, US, Canada, Russia, many small reserves in Europe, Africa, South America, Australia has some, and so on and so forth. While renewables are abundant, so you can look at the distribution in terms of solar and wind energy potential as a multiple of total energy demand. Red is where they are super abundant, so more than 1,000 times the total energy demand, and abundant is where they are greater than 100 times, and replete is where they are greater than 10 times, and stretched is where they are less than 10 times. So there are few places here they are stretched where number of sunny days and winds may not support the demand all by themselves. Okay, solar rooftops alone, 53,000 terawatt hours per year, could supply us with all our electricity needs of 28,000 terawatt hours per year. Only 14% of energy demand comes from crowded places like Germany or Japan that might struggle to find space. So Japan has got issues in terms of space also for growing meat, which they love, for example, right? And for installation of nuclear plants, which spooked them after the Fukushima accident. We recently figured out how to access these renewables cheaply, which means the cost of energy has continuously dropped. If you look at coal and oil since the 1900s, they've had their ups and downs. Coal crashed over a while for electricity in terms of electricity, and then has remained steady or even peaked during the pandemic and after. But if you look at the cost, these are levelized cost of electricity in 2020 dollars per megawatt hours in a log scale. So you can see that there is a tremendous precipitous drop in the cost of energy from solar and wind, as well as P2X fuel with models solar and wind costs. Okay, obviously it's good news. Deployment is going up, funding is going up, costs are going down, and battery storage continues to improve to deal with the intermittencies. But of course there are still many barriers, as we will see. Renewable costs will continue falling on learning curves, so decreasing costs of solar, wind, batteries, and hydrogen past and future. So primary, carrier, and fossil fuels, this is projections out to 2050, and obviously when there are projections we have to always be careful in terms of the assumptions made. So there are observed global average technology costs, and then there are details of probabilistic rights law, because under fast transition scenario forecast under, I screwed that up, probabilistic Wright's law forecast under fast transition scenarios, high progress integrated assessment models, or the International Energy Agency cost projections in these red lines, observed global average fossil fuel prices in this bluish line here somewhere, and the IEA fossil fuel cost projections. The main point is that we expect the cost of solar to continue to drop to 2050, wind to drop as well. Here are the 2050 costs, medians, and 50th and 90% percentiles. Battery costs are expected to drop, both for lithium-ion and lithium-ion EV packs, so consumer cell and EV battery packs. P2X electrolyzers. Oil is expected to do its thing, and it will not be, coal and oil will not completely disappear, but they are just going to get small enough that with carbon capture and sequestration we should hit net zero or net negative. And there is gasoline, of course, very optimistic and rely on technological promises of things like carbon capture, which have to materialize, so one has to always keep an eye out for those. Capital expenditure has already shifted to renewables. Looking at capital expenditure on electricity generation in billions of dollars for fossil fuels has peaked and may be dropping, and non-fossil fuel on the other hand have been growing tremendously, now out above $500 billion by 2020 here. Okay, so renewable generation capital expenditure capex in 2021 was 450 billion, 10 times the level of 20 years ago here. In 2021, 80% of all new electricity generation capital was being invested into renewables, and we have discussed before about how the Russian war has in fact accelerated the deployment of renewables over Europe. This is true for developed markets, which have 88% of the share. China with for 88% of its share in investments, and the global south has also 61% of its capex into renewables. Capex on fossil fuel generation peaked in 2015 and has dropped to below 20% of the total. So that's the total there, and that's the fossil fuel at below 20% of the total. Fossil fuel capex is used mostly to maintain existing assets, not to expand them. So this is like the old saying, the Stone Age didn't come to an end because they ran out of stones, but because the Bronze Age, Iron Age, and so on came along. And the same thing here, that fossil fuels will be left as assets in the ground, not because we ran out of them or peak oil arrived, but because it will become simply not economically viable to keep investing in digging them up. Expected growth rates to 2030 are high. CAGR of solar and wind electricity generation to 2030. So this is the annual growth rate. The IEA's three scenarios: stated energy policies, the advanced policy scenarios, and net zero effects. So you have various scenarios here from STEPS, APS net zero, Rystad 1.7, Rystad 1.6. This is the Bloomberg New Energy Finance Economic Transition scenario, and so on. So they all have their own projections, but the growth rates are still relatively high. This is where we are heading, powered by and powering falling costs. Solar generation in terawatt hours per year, thousands. So here is the Central Technology forecast, and where we need to be for 1.5 degrees C target by 2100, and where we can hit 2.2 degrees C if we ramp up solar in terawatt hours per year more slowly. And in terms of wind, again in terawatt hours per year, in thousands of terawatt hours, there is the Central Technology. You have to see why it drops off here while solar doesn't. There is the 1.5 degrees C requirement. There is the 2.2 degrees C requirement. These again, there is some uncertainty in terms of how the winds will change themselves in terms of global warming response on the dynamics of the atmosphere and so on. So one has to worry about those details, but we are optimistic about the future anyways. 3/4 of all the growth from 2018 to 2021 has been from renewables. So increase in electricity supply 2018 to 2021 terawatt hours. Solar and wind dominate, with fossil fuels adding a little, about 1/3 or so, especially when you combine nuclear, hydro and biomass. So due to the shock and recovery of 2020-2021, it's better to look at the period on a net basis. So 2018 to 2021 is considered to avoid the pandemic shock and also the war. Since 2018, 60% of the growth in global electricity supply, over 1,000 terawatt hours, has come from solar and wind. A further 18% of the growth has come from hydro, nuclear and biomass. Fossil fuels made up less than a quarter of the growth in supply at just 400 terawatt hours. Okay, 400,000, no, that's 400. Okay, 3 key regions for fossil fuel demand for electricity. Organization of Economic Cooperation and Development is up here, and it's plateaued and dropping in terms of fossil fuel demand. China is still growing, and non-OECD, excluding China, have also grown. So China has its own trajectory. China has a strong track record of exceeding its renewable targets even as it burns a lot of coal. So China solar and wind deployment targets and actual gigawatts, you can see the target and what was accomplished by the date, 2015 and 2020. So the actuals here are almost 50 or at least 30% higher than the target. So that the idea is that by 2030 the 2030 target will be met before 2025. Okay, so that's something to keep in mind. The non-OECD story is complex. Fossil fuel demand for electricity in 2021 terawatt hours. Some countries already peaked and some have not peaked in terms of the demand, fossil fuel demand for electricity. South America not peaked yet, so these are peaked, and these are not peaked. Thailand, Vietnam, Malaysia, South Africa peaked. CIS, Central Island states peaked. I should check that. I'm forgetting what I read. Middle East not peaked, India not peaked, Asia and other Africa other not peaked. Asia other is excluding China, India and these countries, and Africa other is excluding these. Okay. India is setting out a new path. India electricity supply terawatt hours. So here we are. 2021 was here, and that's the projection. So solar, wind are going to be a big part of it, and other renewables, but including nuclear. Hydrogen is in there as well. There will be gas with CCS and coal with CCS and oil as well. So India has basically still not completely gone as fast as China or the OECD countries. OECD and China built their electricity systems when coal was cheap and there were few alternatives. Countries with rising electricity demand now have a choice because the renewables are much cheaper. These countries increasingly are choosing cheap, clean domestic renewables. In India, for example, even using the more conservative Bloomberg economic transition scenario, there is little room for growth from fossil fuels. So India in some sense can leapfrog the follies of the other countries that came before and how they grew. Almost all the growth in supply is met by renewable sources. India is taking a very different path to China 20 years ago. So coal electricity supply per person in megawatt hours. China went way up here and India has remained low. So India is making a shift to renewables at much lower coal electricity consumption levels than China did. Chinese coal electricity demand per capita is peaking at around 4 megawatt hours per year. So this is expected to start turning down. India coal electricity demand per capita will peak at around 1 megawatt hour per year, the level where China was 20 years ago. 20 years ago, solar electricity cost around 10 times more than new coal electricity. Today it costs half as much as new coal. So we have to keep those in mind. Anyway, the transition of electricity system will not be easy. So electricity supply in terawatt hours per year from fossil, other, and solar and wind, it's going to be here by 2025, and then fossil and other are expected to drop off. Other will peak here in terms of nuclear, hydro, and bioenergy, for example, and solar and wind will dominate by 2065. So there are many scenarios involved in here, but we can look at a range of barriers that we have to face. So the key barriers to change in terms of challenge, short-term and long-term solutions. So we have variability, so regulation, batteries, and digitization at the short term, efficient, timely use grids and storage at the long term, challenge of land in terms of deploying solar and wind as well as bioenergy, permitting processes and roofs have to be used more, and long-term solution is to continue the deployment. Minerals, more mines, new chemistries. We just talked about minerals and metals for the transition and for the global warming targets. So there is some good news in terms of enough resources being available, but obviously one has to watch out for other barriers. In the long term, efficiency, substitution, recycle, and find resources. Supply chains, build out and diversify. Chinese dominance, we talked about this as well. Alternative supply chains have to be built and different global nodes have to be created. Low income countries, development banks have to help and policies have to come into place, and capital and technology transfer will be required to meet the NDCs and beyond to carry the whole world towards decarbonization and net zero. Petrostates, no barrier to global change in terms of short-term solution and change to survive. So Saudi Arabia is already investing thousands of billions to become a green hydrogen center, and they have also been putting money into research, thinking that when the oil ends they will also become a technology state. So the writing is on the wall and they are moving towards it. And disruption occurs long before the endurance. Just in terms of typology, if you look at electricity supply in terawatt hours from 2000 to 2050, growth, plateau, decline, and end game for fossil fuels. So the disruption occurs long before the end game. So disruption in terms of plateau and decline have started because of the perturbation and solar and wind. So end game is going to be here. Okay, so just keep this in mind. The details of the end game will be determined by technology and policy innovation for the next 30 years. So this is going to be critical. Beware of applying old thinking to the new world. So finally, we should not be surprised by the failure of incumbents to forecast the future without them. In terms of the areas on which people made funny comments, we have trains. Rail travel at high speed is not possible because the passengers unable to breathe would die of asphyxia. We don't even have to worry about who said it. Telephones, what use could this company make of an electrical toy? Electricity, that came from Western Union to Bell. Electricity, Edison's ideas are unworthy of attention of practical or scientific men. Came from Committee of the British Parliament on Edison's work. Oil, drill for oil? You mean drill into the ground and try to find oil? You're crazy. This was prospective drillers to Drake in 1859. Cars, the horse is here to stay, but the automobile is only a novelty, a fad. This was advice to Henry Ford's lawyer circa 1910. Computing, I think there is a market for about 5 computers. This was Watson, the chairman of IBM, in 1943. And renewables, the fundamentals of our lives in terms of energy will not change drastically in the coming 20 to 30 years, which was said by Vaclav Smil in 2022. So let's see how this plays out. Vaclav Smil is an incredibly prolific writer, and he's right in the sense that the energy intensity of our lifestyles is not likely to go down, but who knows how this will play out in terms of not only the energy sources, but whether the new generations will change their fundamental lifestyles in terms of how much they will drive, how much they will consume and pollute, and so on and so forth. Okay, so this is a bit long, but that's okay. Very interesting data and very optimistic message in terms of now having peaked in terms of oil demand, fossil fuel demand for electricity generation, which is great news, of course.